We're going to begin talking about our calculus or math information by talking a little bit about what the College Board or the people responsible for AP Calculus and the exams call the rule of 4. So just to kind of explain to you why we're going to spend so much time verbalizing our mathematics, why we're going to practice so much turning symbols into language and language into symbols. We're going to spend a lot of time working with information given to us in tables as well as in graphs. And the graphs will lead us to our parent functions. Now these are just basic functions. I call them parent functions because when we do translations or reflections or stretching and compressing on these, they lead to baby functions or variations of that parent function. So it becomes really important that we have a great handle on all the aspects of our parent function. So let's talk about what rule of 4 means according to the College Board. So in AP Calculus, we will approach every single concept, and remember, we have to master every single concept from 4 different perspectives. The College Board calls these perspectives analytic, numeric, graphical, and verbal. So analytic is basically the X's and the Y's. It's the equation manipulation, the symbol manipulation. When you think math, this is the kind of math that you generally think of. For my students, generally the analytic way to handle equations is pretty comfortable for you. So analytically, I don't think you're going to have any struggles at all. We love our X's and our Y's. Numerically means that you have to be able to actually apply the calculus concepts to some numerical data. You are definitely going to be given tables of values as opposed to just graphs or just equations when it comes to AP questions. Graphically, obviously, is being able to manipulate and understand information that's given to you in graphical form. Again, most of my students don't struggle with this at all, but you will get very, very good at being able to analyze a graph. The 4th rule, the verbal rule, seems to be the one that my students struggle with the most. Now, I will say I have a lot of practice for this built in for us in our homeworks and our quizzes and things like that, so you will become better and better and better at turning symbols into language and turning language into math symbols. So you must be able to explain calculus concepts in clear, concise, correct English. And you have to be able to do all 4 of these things with or without your calculator. So there's the rule of 4. So this is one of the reasons why we have to delve so deeply into all of the mathematics concepts that we're going to cover. So let's cover just basically these basic functions. Again, I call them parent functions. These are ones that you have to know just automatically. You're responsible for knowing how to draw each of these parent functions. You have to be able to identify where their intercepts are, where their zeros or their roots are, whether they have any symmetries, even or odd symmetry, or no symmetry whatsoever. You must automatically know the value, all X values or input values that are in the domain and also in the range of these parent functions. So let's talk about the constant parent function. Now, this is a constant function. All of the outputs of this function, f of x equals a, lie on the y-axis at the y value of a. There are infinitely many input values for this constant function. So when I look from left to right, all of the x values are covered from negative infinity to positive infinity. So the domain of this function is all real numbers. The range of this function, all of the y output values or dependent variable values, are the one value of a. Everywhere in the xy plane, this function has an x coordinate and a y coordinate of a. This function, this constant function, unless the y-coordinate is 0, will not have any x-intercepts. This constant function, this horizontal line, will never touch or cross the x-axis unless it's the one member of this family where a equals 0. And that is the line that lies on the x-axis and therefore would have infinitely many x-intercepts. Again, the y-intercept for this function would be a. There are no zeros or roots. Frankly, x-intercepts and zeros or roots are the same thing. Your x-intercepts are your zeros and they are the roots of your function. This function does have a symmetry. All horizontal lines in the plane are going to be symmetric about the y-axis. Any function that is symmetric about the y-axis is an even function. We already talked about the domain and the range of this function. So there is the parent constant function known to us as a horizontal line. Here is the parent linear function. This is all other lines in the plane that have a non-zero slope. So if you have a line in the xy plane and it does not have a slope of 0, this is its parent function. All of those lines are some interpretation on the function f of x equals x. This is the parent function. It has one x-intercept, 1, 0, one root, that is x equals 0. It has one and only one y-intercept, that is y equals 0. Now, any kind of manipulation on this parent linear function can move this line up or down in the plane. It can move it to the right or left in the plane. It could actually stretch or compress this line, which for a linear function is just going to deal with the slope of that line. This is an odd function. It is symmetric about the point of origin. The domain of this function is all real numbers. Any x value is legal to put into this function manipulation from negative infinity to positive infinity. And as a result, you will get all real numbers in the range of this function. This is a smooth, continuous function with no holes, no jumps, no problems whatsoever. So you have to know what the parent function of y equals x or f of x equals x, what it looks like in the plane, and be able to draw it. Here's the parent function for all absolute value functions. Remember, it has this V shape to it. The slope that is happening on the left half of this graph is the negative equivalent to the slope that's happening on the right portion of this graph. For our parent absolute value function, the slope to the left of x equals 0 is -1, and the slope to the right of x equals 0 is +1. The point where those two lines meet is called the vertex of this absolute value function. When we start talking about moving this up or moving it to the right or the left or moving it down, when we start talking about moving this around and talking about all the baby functions that come from this, that vertex point is going to be very important to us. For the parent function, the vertex point is the origin, 0, 0. It is the only x-intercept and it is the only y-intercept of this parent absolute value function. This is an even function. It is a direct reflection over the y-axis. So it is symmetric about the y-axis, which means it is an even function. The domain of this function is all real numbers. All x values from negative infinity to positive infinity lie in the domain of this function. However, the range starts and includes y equals 0 and goes to positive infinity. So here is the parent absolute value function. Here's the parent quadratic function. We also call this the graph of a parabola. This function is f of x equals x squared or y equals x squared. The parent function opens up. The parent function has a vertex point at the origin. It is the only x-intercept, the only y-intercept. It is symmetric to the y-axis, so this parent function, x squared, is an even function. The domain of this function is negative to positive infinity, and as you can see from the graph, the range of this function is 0, including 0, all the way to positive infinity along the y-axis. Here's the parent cubic function. The parent cubic function, f of x equals x cubed, is an odd function. It is symmetric to the point of origin, which makes it an odd function. It has one x-intercept, x equals 0, and one y-intercept, y equals 0. The domain and the range are both all real numbers.